guys, welcome to another version of Math Inc. Today we're going to talk about the properties of numbers, and then I'm just going to do a small demonstration. So I'm going to talk about the 9 first properties of numbers, which are probably the most important and elemental ones, from which we can derive most of the algebraic properties we know of. The first one is the associative law of sums, that a plus b plus c is the same thing as a plus b plus c. The second one is the existence of an identity, 0, which doesn't modify a. So a plus 0 is the same thing as 0 plus a, which is the same thing as a. I know most of these will sound very dumb, but they are very important to know and to understand. The third property is the existence of an inverse while you're adding. So a plus minus a is the same thing as minus a plus a, which is 0. And that's the way we actually define a subtraction, as the sum of a negative number. The fourth property is the commutative law, which a plus b is going to be equal to b plus a. So it doesn't matter in which way you add the two numbers. The fifth law talks about multiplication, and it's the associative law as the first one, which a times b times c is the same thing as a times b times c. The sixth law is the existence of an identity, which a times 1 is the same thing as 1 times a, which is the same thing as a. The seventh property is the inverse. So a times a to the minus 1 is the same thing as a to the minus 1, or a inverse times a, which is equal to 1 for all a's that are 0. A to the minus 1 can be defined as 1 over a, and a cannot be 0 because a, 0, times a to the minus 1, 1 over 0, would equal 0 over 0. And that is undefined. So that doesn't exist in real numbers. The eighth property is the commutative law, which a times b is going to be equal to b times a. The ninth and final property is the distribution law, which a times b plus c is the same thing as a times b plus a times c. And with these 9 properties, I'm going to prove the law that everyone talks about in primary school, kindergarten, that says that 2 negative numbers multiplied will give a positive answer. So I want to show that minus a times minus b is going to be the same thing as multiplying a times b in positive numbers. So the first thing I want to show is that minus a times b is actually the same thing as a times b, the product in negative numbers. And to do that, I'm going to have minus a times b plus ab, which is the positive product, and then I'm going to factorize the b. So I'm going to have b times minus a plus a with the distribution law, and minus a times a with the third property is 0, so b times 0 is going to be 0. So this whole thing is 0. Now I'm going to add a times b negative to the whole equation on both sides. So I have minus a times b plus a times b plus the negative product of ab. Then on the other hand, I have the factorization of b times minus a plus a, and I'm going to add the negative product of ab. With that, I know that these two terms actually equal 0, because I have the positive product and the negative product, and it's the same thing as if I was doing a plus minus a equals 0. So this whole thing equals 0 and will not modify my first product, because that's the identity, 0. And on this other hand, minus a times a, we already knew that that was 0, so this whole term is 0. So now we have proven that minus a times b equals the negative product of ab. And with this property, I'm going to use it in this equation, which is going to be the negative a times negative b plus the negative of the product ab. And now I'm going to rewrite this with the property we just discovered. Minus a times minus b equals minus a times plus b. So this is the same thing over here. And this, I'm going to use the distribution law to factorize the minus a. So I have minus b plus b, and minus b plus b is 0, so minus a times 0 is 0. So this whole thing again is 0. Now I'm going to add the positive product ab to both sides. And when I do that, I have negative a times negative b plus the negative product of ab plus ab. Okay? And on the other hand, I'm sorry that it didn't fit on the same line. I have negative a times negative b plus negative a times b plus ab. Now, as before, this is the positive product and this is the negative product, so these are going to cancel each other out, and I'm going to have negative a times negative b on one side, and on the other side, I'm going to do the factorization with the distribution law. The minus a, I'm going to factorize minus b plus b, so I have b, and I have this, and this whole thing is 0, okay? So negative a times negative b, and this is 0, is going to be ab. So we just proved what we wanted to prove, that negative a times negative b is equal to ab, positive. Another way to look at this, much easier and faster, is by looking at this equation. We know that negative a times b plus ab, all of this was equal to 0. And on this other hand, we have negative a times negative b plus negative a times b is going to be equal to 0. So I have this and this, which are the same term, and when you add them, you get 0. So the only way that you have minus a plus times b plus ab equals 0 and minus a times b plus minus a times minus b equals 0 is in fact minus a and plus ab are the same. So we get this answer again. Minus a times minus b equals ab. Thank you very much. Enjoy Math Inc.